Hi everyone, we're going to look at theoretical compound probability. Now, compound probability is kind of like a compound word. A compound word is composed of more than one word. So a compound probability is multiple events. We're looking at multiple things and saying, what is the chance of this and this other thing happening at the same time? So it'll be a little more complicated than just a normal theoretical probability problem. So what we typically do for these to figure out all the different combinations is we use tree diagrams to kind of illustrate and keep track of all different ways to make a combination. So the first one here, we've got flipping a coin and flipping another coin. So we got two coins. So what we do to make a tree diagram for this is we just first show the options for coin one. So coin one has options of heads and tails. And then off of each of these options, we're going to draw the options for the other coin, coin two. Now they're going to be the same options, but they're going to be off of each of the first options. So after we get heads, we could get heads again, or we could get tails. And then off of the tails from the first coin, we could get heads, or we could get tails. And this gives us our sample space of combinations. So our sample space is just following each branch. So heads, heads would be the first branch, the first combination, or we could get heads and then tails, the next combination, or we could get tails and then heads, which is different from heads and then tails, or we could get tails and then tails. So there's actually 4 different combinations, and the 4 comes from 2 combinations for the first coin and 2 combinations for the second coin, so we have 4 total because it's 2 times 2. Gives us the total number of combinations we're going to have. So now we look at what it's asking. The probability, what's a theoretical, so out of our total number of outcomes, there's 4 total. So out of those 4, how many times could we possibly get tails for coin 1 and tails for coin 2? So we look at our options here in the sample space. So tails for both coins only happens once. So the probability of tails, tails would be 1/4. Let's make it a little neater here. So the probability of tails and then tails is 1 out of 4. Now we can also find this by finding the probability of tails for the first coin times the probability of tails for the second coin, because that would be 1/2 for the first coin, 1/2 for the second coin, gives us 1/4, the same answer. So we can do it either way, looking at your tree diagram, counting the number of times we get what we want out of our total, or taking each probability and multiplying it, you'll get the same answer. For the next one here, we've got a coin and a 6-sided die, so we're going to start the same way. So our first event is, again, a coin. So we've got heads and tails. And off of that, we're going to show all the options for a 6-sided die. So it's going to be quite a few branches here. So off of heads, we got 1, 2, 3, 4, 5, or 6. And again, off of tails, 1, 2, 3, 4, 5, and 6. A little bit sloppy, but hopefully you get the idea. Then our sample space is all the combinations of these. So heads in 1, heads in 2, heads in 3, heads in 4, heads in 5, heads in 6. And then all those same ones with tails. So tails in 1, tails in 2, tails in 3, tails in 4, tails in 5, and tails in 6. So how many total options are there here? Where there were 2 for the coin, 6 for the die. 2 times 6 should be 12 total combinations. And we see them right here. There's 6 with heads, and there's 6 total with tails. So there's your 12 different combinations. Now we're going to look and see what the problem is asking. The probability here for tails for the coin and 4 on the 6-sided die. So where do we see tails and 4? That only happen once. So the probability of tails and 4 happen 1 time out of 12. Or again, we could do probability of tails times the probability of 4. Probability of tails is 1/2. Probability of 4, there's only 1/4 out of 6, which is where the 1/12 comes from. So either way you do it, you get 1/12 for the probability of tails and 4. We're going to need this little multiplication method to make the next problem a lot easier to do, because now we're going to talk about cards. If I pick 2 random cards, we're going to be here quite a while drawing out all the different ways we can get a card out of a 52 deck. So it'll be a little bit easier if we don't do a tree diagram here. So the probability of hearts for the card 1 and 3 of clubs for card 2. So what we're going to do here is do each probability separately. So the probability of hearts, well, hearts is a suit. So for the suit here, there's 4 suits. So it would be 1 out of 4. Or we could call that 13 out of 52, since there's 13 heart cards out of 52 cards total. It'll be a little bit easier to use the simplified form. 1/4. That would be the probability of hearts. Let's use a heart symbol this time, so you know it's not heads from a coin. There we go. And then probability of 3 of clubs. Okay, well, how many 3 of clubs are there in a whole deck of 52? Only 1. There's 4 3s, but only 1 that's a 3 of clubs. So what we do here is we just call this 1 out of 52. So the probability of hearts on the first one and 3 of clubs on the second card, if you put that first card back, would be 1/4 times 1 out of 52, just multiplying each of those individual probabilities, and that gives us the probability 1 out of 208. So that would be our probability of this event happening just by multiplying those two events together.